This podcast is on practicing the calculation of the Pearson correlation coefficient. We will practice on two samples of data from a single data set of French presidential elections. We will assess the meaning of the correlations after we calculate them. Let us remind ourselves of the basic idea behind our calculation. The Pearson correlation helps us to determine the extent of the symmetry between two variables, measured at either the interval level or multi-categorical ordinal level. The greater the symmetry between the two variables, the stronger the correlation, either negative, which means the variables move in the opposite direction, or positive, which means they move in the same direction. The less the symmetry, the weaker the correlation, as the two variables are not in sync. We determine the extent of the symmetry based on taking the z-scores for each case of the two variables and matching the z-scores by case, summarizing those matched z-scores, and then dividing by the total number of cases minus 1 to account for a degree of freedom. We remind ourselves of the formula for correlation. It's the sum of the z-scores for each case value for x. In other words, the case value itself, from which it is subtracted the mean value for the variable, with the result being divided by the standard deviation for the variable, multiplied by the z-scores for each case value for y, with that summation being divided by the total number of cases minus 1 degree of freedom, since we have a sample of data. Our data come from the world of French presidential elections. In France, the public votes every 5 years. It used to be every 7 years, for the President of the Republic. It is a monumental occasion with high levels of turnout. Around 80% of the eligible public votes. The interest is keen as the President holds a great deal of power in the French system, not unlike a US President. There is a twist in France, though, as the President appoints a Prime Minister who manages the affairs of the National Assembly, the legislature. As in the US, however, there can be divided government, or what the French call cohabitation, where the Prime Minister must command a majority of the Assembly seats. So it's possible that the Prime Minister will be of a different ideology than the President. It is an interesting governing system. The French election system is also interesting, as it is a runoff system, not unlike that of Louisiana, the most French of the US states. In the first round, it is a free-for-all, the top vote-getter avoiding a runoff if she or he receives a majority of the vote. But if not, the top two vote-getters advance to the second round. The old saying goes, the French voter votes with her heart in the first round and with her head in the second round, finding the best compromise candidate, if necessary, to choose as the next President of the Republic. In our analysis, we are interested in the second round vote only. We divide our data into two subsamples, one to capture a historical peek at the elections, the other to acquire a more modern sensibility. Each data set is very small, only 5 cases each, but they cover similar time spans, around 2.5 decades each. We would like to see if there is a strong or weak relationship between the vote for the opposition presidential candidate of the party opposite of that of the president and the state of the economy. We hypothesize that the stronger the economy, represented by annual growth of gross domestic product, GDP, the less support the opposition party candidate attracts, as the public rewards the presidential party candidate with its support for a well-performing economy. We further hypothesize that the weaker the economy, the opposite the effect, as the presidential party candidate gets punished for bad economic performance and the greater the vote for the opposition candidate. We can take a first cut at our hypotheses with a scatter plot of our data points. I've put a linear trend line on top of the points so that we can glimpse the direction of the points. We can see that there's a pretty large outlier, which happens to be the presidential election of 1981, where François Mitterrand, a challenging socialist candidate, defeated the incumbent Valéry Giscard d'Estaing, the incumbent rightist candidate. The economy was performing poorly, and Giscard paid with the loss of votes. We should hypothesize the relationship to be negative, as the line drops from top left to bottom right of the scatterplot. We start the calculations of our Pearson correlation with subtracting the mean value from each case value for the two variables, GDP growth, x sub I minus x bar, and opposition vote percentage in the second round of the presidential election, y sub I minus y bar. Be sure in these calculations to keep the negative results negative. This will be important in determining the correct sign of the correlation. We then standardize these deviations from the mean value by dividing by the standard deviations. The signs of the z-scores will reflect whether or not the case value is above or below the mean value. The larger the z-score, the greater the deviation from the mean value. Note the 1981 case, where there is a high negative z-score for the GDP variable, an unusually small economic growth rate, and a high positive z-score for the opposition vote variable, an unusually large opposition vote. Next, we multiply the z-scores for our x variable by the z-scores for our y variable. Unlike in our covariance calculation, these scores are standardized by the standard deviation, so the products will be much smaller and allow us to interpret them on a scale. Finally, we summarize our products for each case, and we conclude the calculation by dividing by the denominator, the number of cases minus 1. Thus, our correlation is negative 0.90. This is, according to the scale we looked over in the previous podcast, a strong correlation since it is below 0.50, negative 0.50, and is of course a negative correlation. We are led to believe that for this time period in French presidential elections, the worse the economy did in the year prior to the election, the better the opposition party candidate did in the second round of the election. The second subsample consists of French presidential elections from 1995 through 2017. Again, 5 presidential elections, as in the first subsample. We can see two things right away about this data set. First, the range of values for annual GDP growth is much narrower in this data set than in the previous data set. Second, due to an extreme outlier in the 2002 elections, the extreme right-wing candidate from the National Front, Jean-Marie Le Pen, received more votes in the first round than did the mainstream Socialist Party candidate Lionel Jospin, so competed in the second round against the incumbent Gaullist candidate Jacques Chirac, and got trounced. There will be a fairly wide range of values for the opposition candidate vote in this data set. When we examine the scatter plot, we see a less apparent pattern to the data points. They appear to be scattered across the page in a horizontal line. In fact, the linear trend line is almost flat and drifting ever so slightly from the top left corner toward the middle right. Thus, we would expect the correlation to be negative and weak. Our calculation process is exactly the same as in the first subsample. You can see that the deviations from the mean value for X, GDP per capita, are relatively narrow, while the deviations from the mean value for Y, opposition vote percentage, are relatively wide. Also note, there are two cases where the signs of the deviations are different between the X and the Y variables. In 1995, negative X and positive Y, and in 2017, a positive X and a negative Y. Next, we calculate the z-scores for X and Y. Be sure to keep the signs correct as they heavily influence the interpretation of the correlation coefficient. Remember as well to go at your own pace through these slides. Next, we find the product of multiplying these z-scores. Since these products look pretty small, we can conclude already that this correlation will be smaller in magnitude than that of the first subsample. Indeed, our final part of the calculation process shows that the sum of these z-score products is only negative 0.70. So dividing by the total number of cases minus 1 yields a small correlation. R equals negative 0.18, which is a weak negative correlation. What conclusions about French presidential elections can we make based on our two subsample calculations? First, the correlation between the state of the economy and the vote for the opposition candidate is variable based on historical era. The 1965 through 1988 era had a much larger correlation than does the 1995-2017 era, where the correlation has largely disappeared. Thus, this type of economic voting in France is much reduced, and other factors will need to explain French presidential voting patterns. As well, correlations must be reassessed over time as they can change. Keep on paddling away and you'll learn more and more during this course. Thank you for listening.